Hi, this is Dr. Pierce McCarty from Minneapolis, Minnesota, and today we're going to look at the use of the 2.8 millimeter Y-knot RC to repair this crescent-shaped full-thickness tear of the supraspinatus. We're going to use a transosseous equivalent technique. Here we're beginning with the standard step of lightly abrading the greater tuberosity. It's very important to maintain cortical integrity so that the Y-knot RC can have adequate purchase beneath the cortical surface. So we're simply painting the surface to get a light blush from the cortex. Positioning our first Y-knot RC, it has a sharp tip which allows you to position the anchor easily on the cortex. The sharp forked tip allows you to essentially grasp the cortex and position the anchor wherever you want it. I'll typically insert the anchor to the midway point of the hashed lines, and then a firm pullback is required to set the anchor beneath the cortical surface. One thing you may notice was the efflux of marrow elements that came out when we set the anchor, and I've noticed that there anecdotally is a significantly greater amount of marrow efflux with this type of anchor than a typical screw-in anchor that gives you aperture fixation. Subsequently, we're going to pass the sutures from the Y-knot RC using a standard antigrade needle punch device, and we are simply selecting and passing these in a mattress fashion through the full thickness of the rotator cuff. One wants to make sure that if there is delamination that both lamina are captured with this medial row. This is a double-loaded Y-knot RC. There is a triple-loaded variety as well, but with the transosseous equivalent technique, I will typically only use a double-loaded anchor. Here's our second Y-knot RC being placed in a percutaneous fashion. There's good visualization there of the element of the anchor that will actually expand in subcortical fashion, which provides the excellent purchase. Again, we're selecting our spot at the cortical margin and driving the anchor in without having to tap a pilot hole. And also, once again, I will typically insert the anchor to the midpoint of the hashed lines. A firm pullback will set the anchor along the subcortical into subcortical position. And once again, we're going to select our sutures and pass them in mattress fashion. Here we're taking an additional step to attempt to stimulate marrow efflux from the cortex. We're simply taking a very fine awl and micro-fracturing the greater tuberosity in the region of the tear, generating our own PRP, if you will. What we're doing here is simply standard arthroscopic knot. We use a modified Revo, but any large number of knots can be performed. We'll tie and cut one set of sutures from each anchor, and then we'll take the other set of sutures in standard transosseous equivalent fashion, drape it over the lateral margin of the rotator cuff, and secure it with a 4.5 millimeter pop lock anchor. We have just tapped the hole for the anterior of the two pop lock anchors that we're going to use. Here we are driving that pop lock anchor into position after we have passed the two suture tails through the locking mechanism of the anchor externally. Once the mechanism is fired, the sutures are firmly locked. We can see the lateral tip of the anchor in its appropriate position there, and once we have cut the suture tails, they are flush with the cortex. Here we're placing our more posterior of the two 4.5 millimeter pop lock anchors. Here we have, again, in standard fashion, passed the two tails of the suture through the pop lock anchor and then inserted it, fired the locking mechanism, and cut the suture tails flush with the cortex. Now we've completed our repair of this medium-sized, full-thickness crescent-shaped tear. It did have excellent mobility, so it was an adequate or an appropriate candidate for a transosseous equivalent. We can see we have excellent compression and anatomic repair with no dog ears. A standard rehab protocol will be followed with approximately 4 weeks of sling immobilization for this size tear, followed by standard progression and range of motion.